Hi class, let's take a look at example 3. And in this particular one, we have to find a couple of the values for information. And in this case, this one says that the standard deviation of all FICO scores is this much. So that means that technically sigma is equal to the 58.9. This is technically your alpha, so this is 0.01, which means that the level of confidence is technically at the 99%. And then the last portion is, well, the claim happens to be stated that has to mean greater than 678. So let me just start with the type of test that we're performing. So in this case, because the values of sigma is equal to 58.9, this is going to be a z-test. And then also, the actual claim is that mu it's greater than 678 for the credit scores. Now, the next portion of the problem is we need to state HO and HA. So state HO and HA. So let me just rewrite them as HO and HA. The claim is greater, so in this case mu is greater than 678. The next portion is HO, so in this case mu is equal to 678. Now let's take a look at your critical values. In this case, well, let me write them here. Now your critical values are based on C. So in this case, alpha is equal to 0.01. And in this case, the values of, well, C is equal to be 0.99. And then we're actually doing a right tail test because of the greater. So the right tail test is going to look like this particular scenario, where alpha happens to be to the right. So as we come up with the critical values, let me just write them here. And this is, remember, a bell shape. This technically C score happens to have total area to the left to be 0.99. So to find this one, you can simply do a inverse norm of 0.99. Since you have the level of significance to be 0.01, so 0.99 to the left, and in this case we're looking at 2.33, rounding to 2 decimal places. So this is 2.33. Give me just a second. So the z value is equal to 2.33. Now let me just shade this portion because this is going to be your rejection region. If your test statistic falls there, you reject HO. If it falls here, you fail to reject. HO. Now, the next portion is your actual evidence, or in this case, the actual test statistic. So give me just a second. And your test statistic, it's basically here. So our test statistic, it's going to be this specific formula. So let me write it up. So our test statistic, so it's gonna be a C score that technically has the following values. So you're gonna have to get x bar minus technically the values of mu divided by sigma over the square root of n. Now, we don't have the actual mean of the sample. So to obtain the mean of the sample, run a one variable stats. In this case, I already have this, and actually I put it under L2. So run a one variable stats and the mean of the sample, confirm that you're matching. I'm getting 680.58. So in this case, x bar is equal to 680.58. So we're looking at 680.58 minus mu, that would be 678. So 678, we're using mu is equal to 678 over sigma's given. So sigma was equal to 58.9, and then n is equal to a total of 12 values. So this is the important information that we technically need from the data set. Is not given, and it's actually not given. So in this case, we're simply looking at 58.9 over the square root of 12. So please evaluate that and see if we're matching. I'm getting that this is 0.1517, rounding to 4 decimal places. Please evaluate it and be careful to make sure that you're putting the actual parentheses there. Now we're actually not done. From here, we're actually gonna draw the conclusion. And the conclusion is as follows. Since 0.1758, in this case, actually 0.1517, it's on this portion here. Keep in mind that this is 0, so this actual value, it's gonna be somewhere in here. We land on the fail to reject a Joe. So our main conclusion is going to be to fail to reject a Joe. And you can simply say because the test statistic of C, it's approximately 0.1517, is less than the critical value, which is equal to C, which is approximately 2.33. So it falls to the left of it. In this case, we're just saying that it happens to be into the fail to reject region. Now, let me show you how to run this particular one, and you're using the shortcut. So the actual command is going to be stats, then you're going to go to actual test, and you're going to activate the z-test. Within the z-test, you're activating data. Make sure you evaluate everything as you're given there. So the mean of the population is 678. Standard deviation is 58.9. I have everything under L2, and in order for activate the p-value, this is a greater since the claim is on greater. So please run it. And what we should see here is the following output. And that is with respect to the following. So you technically have the test statistic already calculated is here. 0.15. Oh shoot. Let me double check this value. Give me just a second. Okay, so this 0.1517 is just rounding because we rounded the mean of the sample. So the calculator actually has more values. You end up with 1519 there, which is not that bad, but the software would have marked it wrong. And in my calculator, I'm getting 0.1517. So that's what we're getting there. If the software for the homework wants technology, then it wants that value there, which is using basically not the 58, but everything else from the mean. Then we're looking at the following. So your p-value, it's going to be retrieved from the calculator. So let me write it here. Your p-value, it's approximately, and it's given in here by this p. So 0.4396. So 0.43. Now, your p-value actually represents the following. So when you're looking at the shape of the sample, these are going to be z-scores. And the z-score that you're looking at is, well, if this is 0, not to scale, but it's supposed to be a little bit to the left. So I'm just going to put it there, 0.1517. And the area to the right happens to be your p-value. So we're calling the actual area to the right of the actual sample the actual p-value, which is given automatically here by technically 4396.